Hello friends, in today's question, a cylindrical solid mass 10 raised to the power minus 2 kg and cross-sectional area 10 raised to the power minus 4 meter square is moved parallel to its axis, the x-axis, with a uniform speed of 10 raised to the power 3 meter per second in the positive direction. At t is equal to 0, its front face passes the plane x is equal to 0. The region to the right of this plane is filled with stationary dust particles of uniform density 10 raised to the power minus 3 kg per meter cube. When a dust particle collides with the face of cylinder, it sticks to its surface. Assuming that the dimension of the cylinder remains practically unchanged and the dust particle sticks only to the front face of the cylinder, find the x coordinate of the front of the cylinder at t is equal to 150 second. So it is given that a cylinder is moving in the positive x direction. So let us suppose this is our x direction and this is our y, and cylinder is moving in this way. And it is given that at t is equal to 0, its front face passes the plane x equal to 0. And there are some dust particles which are, you can say, on the positive x-axis. So as soon as it passes the plane x equal to 0, let us suppose this is the position of the cylinder, and during this process, because there are some dust particles, the dust particles are going to stick on the front face of the cylinder, and we assume that this is the thickness up to which the dust particles stick to the front face of the cylinder. So we say let this is thickness is denoted by x, and before coming contact with the dust, let us suppose its velocity is given as u, and here it is moving with the velocity of v. Now in this case, the velocity of cylinder as well as velocity of dust particles will be same. So we can say x is the thickness of the dust particles. So in this case, there is no external force, so we can use the conservation of momentum. You can say in the absence of external force, by conservation of momentum, you can say initial momentum of the cylinder plus initial momentum of dust particles will be equal to final momentum of now it will be the combination of cylinder as well as the dust particle, because they will be moving together with the same velocity. So it will be final momentum of cylinder plus dust particle. So we can write this in the form of the equation. The initial velocity of the cylinder is taken as u. Okay, so let me write it here. u is initial velocity of cylinder. So in the equation form we can say m, which is the mass of the cylinder, u plus 0, initially dust particles are at rest, and the final momentum will be mass of the cylinder plus capital M multiplied by V. Here we can write that M is equal to mass of cylinder and capital M is mass of the dust particles accumulated on the in the thickness x. Mass of dust particle on the face of cylinder having x thickness. So therefore, you can simply write it as that our mu will be equal to m plus capital M multiplied by V. And for the mass of the particle, dust particle, which is accumulated on the, you can say, face of the cylinder, that mass, you can say mass can be given as density multiplied by area and the thickness. So here rho is the density of dust particles, A is the area of the face of the cylinder, area of the face, or we can say cross section, of cylinder, and x we already know is the thickness of the dust accumulated. X is the thickness of dust particle on the face of the cylinder. The face of cylinder. So we can substitute the value and we can calculate the velocity, that is m initial velocity divided by m plus capital M is given as rho ax. Now velocity can be written in terms of the dx by dt. So we get mu, and this comes as m plus rho ax. We cross multiply it. We get this as m plus rho ax multiplied by dx is equal to mu multiplied by dt. Now in the question it is asked that you can find out value of x, and with respect to time, when the time is 150 seconds, so we are going to integrate both sides. This will be from 0 to x, and this will be our 0 to 150. So we get this as mx plus rho a x square by 2 is equal to limit 0 to x, and this will be mut for the limit 0 to 150. We substitute the values along with other values. The mass, okay, let me sort it first of all. Mx plus rho a x square by 2 is equal to, this comes 150 mu. Now we can substitute the values. The mass is given as 10 raised power minus 2. Yeah. So this becomes 10 raised power minus 2x, plus density is given as 10 raised power minus 3. Area is given as 10 raised power minus 4 divided by 2 x square, and this will be 150 into 10 raised power minus 2, and velocity is 10 raised power 3. So we can write this equation as, this will be coming as 1500. So we can write 1500 is equal to 10 raised to the power minus 2x, plus this will be 10 raised to the power minus 7 x square by 2, or we can solve it in terms of quadratic equation. We can say this will be x square plus 2 into 10 raised to the power minus 2 into 10 raised to the power 7, and this will minus 1500 into 2 into 10 raised to the power 7 is equal to 0. So we can say this is equal to x square plus 2 into 10 raised to the power minus 5, and this will be coming as 3 into 10 raised to the power 10, 0. Sorry, I missed the x. Here it will be x and here it will be x. So we can factorize it. We can say x square plus 3 into 10 raised to the power minus 5. Sorry, it will be plus. This will be 5x and minus 10 raised to the power 5x minus 3 into 10 raised to the power 10 is equal to 0. Therefore, we can take x as common from the first factor. X, this will be x plus 3 into 10 to the power 5x minus, taking 10 to the power 5 from the second one, this will be x plus 3 into 10 to the power 5 is equal to 0. We can arrange them. X plus 3 into 10 to the power 5 and x minus 10 to the power 5 is equal to 0. So in this case, either x plus 3 into 10 to the power 5 is equal to 0, or we can say x minus 10 to the power 5 is equal to 0. So from the first, we are going to get this as x is equal to minus 3 into 10 to the power 5. In the second, we are going to get x is equal to 10 to the power 5. And obviously we are going to you can say neglect this one, not reject, but because it is given that the dust particles are, it is moving in the positive x direction and passing the plane x equal to 0. So all the dust particles are in the positive x part. So we are going to neglecting it. Neglecting this value. So we are supposed to find out the x coordinate of the front of the cylinder. You can say this is the x coordinate of the front of the cylinder. At t is equal to 150 seconds. So this completes the question. Thank you.